Hello students. So let's try to solve one very interesting problem from JEST 2023. And this problem is from classical mechanics and mainly central force problem. So let me explain first this question and then we will solve it. So this question is a wonderful question. So whenever you want to revise central force problem, this is enough to revise each and everything. So what is given? A particle of mass m is equal to 1 kg is interacting with potential interacting with force actually given that force is minus kr, and this is your force, and it has some angular momentum that is root 2 kg meter square per second in the term of unit of angular momentum, and the value of k is also given, and it is asked in the question for the energy E is equal to 3 joule. If your energy is 3 joule, then in which region particle is going to bound it for a annular space, means that for a two-dimensional space, and you have to just calculate in which region that your particle is bounded. But option is very interesting, so first we will solve it and then we will try to match the option. So what we have, so obviously we have this particular force, so this force is given by minus kr, so I can write my force is nothing but minus k r cap. So this is my central force problem. And this can be defined by minus del V upon del R cap is equal to minus KR R cap. And from there, we can easily find the value of potential. And this potential is nothing but half K R square. So this is a wonderful potential. And when we are going to plot the V effective for this particular potential, so V effective is basically L is angular momentum. So L square upon 2m R square plus potential energy. So that is your half KR square. So this is your V effective. And when you are just going to plot it, then your plot is something like this. So this is your V effective versus R. And now if you have two turning point, then obviously the particle is bounded between these two turning point. If you have one real turning point, then that will be circular in nature. So here only two possible is there. Either this particular particle is moving in circular orbit or your elliptical orbit bounded between these two turning points. So we have to just check whether we are getting how many turning points. So for that, what we have to do, we have to write the equation of energy, and this equation of energy is half m r dot square. This is translation kinetic energy. We can write my rotational kinetic energy as L square by 2m r square, because L is given the angular momentum, which is constant in nature because we are working for the central force. And we have potential energy. The potential energy is VR, and this value is equal to 1 by half kr square. Now, what is beautiful part of turning point? The beautiful part of turning point is that at r is equal to r minimum or maximum. So at r is equal to r minimum or maximum, we have r dot is equal to 0. And we have to check whether we are getting two real r minimum or maximum or one only real r minimum or maximum. So this is very interesting. If we are getting one only r minimum or maximum, or that is r minimum is equal to r maximum, that is one turning point, that means orbit is circular in nature for that particular radius. But if you are getting two real points, that means the particle is bounded. So let's try to check it. And this is a very important concept, that at the turning point, the translation kinetic energy is 0. And so my total energy E is given by, that is L square upon 2m r square plus half k r square. Now everything is given in your parameter. So E is basically 3 unit and L is 2 unit. So that, sorry, root 2 unit. So this is 2 by 2 into m is 1 r square, and this is half, and k is 2 into r square. So we have one particular equation, and this equation is 3 is equal to 1 upon r square plus r square. So if we are going to solve this particular equation, and we can easily solve it, we have equation in form of r to the power 4. So I am just using this space to solve this thing. So when we are going to solve this equation, then this equation is r to the power 4 minus 3r square plus 1 must be equal to 0. And from there, we can find the value of r square. And that value is equal to 3 plus minus b square. That means 9 minus 4 by 2. And this value is r square. And from there, what we can, and this value is r square, is given by 3 plus root 5 by 2 and 3 minus root 5 by 2. And you can check, this is also positive, this is also positive, because root 5 is less than 3. So both are positive. That means we have two, one is r minimum and one is r maximum. So that means we have two real point here. So we have two real point here, and we can get the value of r minimum and r maximum as, so we can get the value of r minimum is equal to 3 minus root 5 by 2 to the power half. And what will be r maximum? R maximum is equal to 3 plus root 5 by 2 to the power half. So for energy, if my energy is 3 unit, so suppose my energy is 3 unit, we have two turning points. So if we are getting two turning point, so this is my r minimum and this is my r maximum. And what will happen? My particle is bounded between these two turning point. But these two turning point at this point and this point, hence my r dot is equal to 0. So only we have rotational kinetic energy, only we have centrifugal term. So at these 2 points, the particle will exactly behavior of circle. So when you will see the option, then this option is very interesting. The option is very interesting, and I am just going to read the correct option. The correct option is C, and it is given. The particle is bounded within the annular region, describing by two circle with radius root under 3 minus root 5 by 2, and another radius is root under 3 plus root 5 by 2. So these are the two radius here and here, which is actually turning point. And at this 2 point, the particle is actually behaving as a circle. So this is very interesting. So when you will solve it, then when you will go for the all option, then option is very complicated. They have given in term of physics, not only in term of the find the value of turning point. So here you have to identify at this point and this point, the particle, the behavior of particle or behavior of orbit is exactly like circular. So my particle is bounded between two circular orbit whose radius is r minimum and r maximum, and this is your classical allowed region. So we will go for answer C. It's a wonderful problem. A student, I will suggest you, if you want to go for this particular problem, if you want to revise central force problem, if you want to revise the nature of orbit, just go for this problem and try to read all 4 options and try to read when other option will be there. This is very interesting. Suppose अगर आपके पास कुछ ऐसा स्टेटस होता कि यहाँ पर एक ही r की रियल वैल्यू आती और दूसरी 2 आपकी इमेजिनरी वैल्यू आ जाती, एक 0 आ सकता था. दिस काइंड ऑफ थिंग कैन बी हैपन. अगर ऐसा होता तो आपकी ऑर्बिट निश्चित रूप से यहां होती और उस समय सिर्फ आप सर्कुलर ऑर्बिट के बारे में बात कर रहे होते. So thing is that we have to do mathematics, and then we have to analyze this mathematical thing with our physics, and this is beauty of this particular question. So students, try yourself, and if you have any suggestion, any doubt, ask me. Thank you.